So this lesson will be on inequalities. On the GD, there is a little bit of this on there as well. So let's take a look at what an inequality is. So there's going to be basically 4 different inequality symbols that you'll come across. And again, an inequality basically connects two things that are unequal. So things that are unequal is basically what an inequality represents. So this symbol here is less than symbol. A lot of times, you think of like I don't know if I can draw a really good picture of this guy, but you got this crocodile guy. A lot of times they think of it as a crocodile that it's got like this mouth here. This mouth kind of makes an inequality symbol. So it always eats the bigger value. So if you get confused on which symbol is what, always remember that the alligator will always eat the bigger one, and that will always make it go in the right direction. But this actually is less than symbol. This actually means is less than or equal to. So it actually has two meanings, less than or equal to. This is the is greater than symbol, and then this is the is greater than or equal to symbol. So those are the main 4. On the GD, you may come across having to solve an inequality. Solving an inequality is going to be very similar to like solving an equation. And a lot of times, one extra thing you'll have to do is sometimes the solution will be illustrated using a number line. So if I'm going to solve this equation, or actually solve this inequality, we treat this just like we would solving an equation. You basically are trying to get the variable by itself, get x by itself. And remember, the first thing we have to do is get rid of the 0 pair, or get rid of the addition of the 2 by using a 0 pair. So the opposite of adding 2 would be to add a -2. So if I add a -2 here, remember the property of equality means you would have to add a -2 to the other side as well. Or some people subtract 2 on both sides. So then I just draw my little line to get my new inequality. So a 2 plus a -2, that actually will 0 out. So we can cancel that out. So this brings down to 3x. And then we have our less than symbol. And then 8 plus -2, that's going to end up being then a 6. Our next step is to make this coefficient turn into a 1. And since this is multiplication, what we do is we divide each side by 3. So our fraction bar is our division symbol. So the 3's divide out, which makes our coefficient turn into a 1. So x is going to be then less than 2. So that's going to be our solution. Any number less than 2 should satisfy this inequality. So if I want to test this, so 3x plus 2 is less than 8. If I want to actually verify that that's true, I can pick a number less than 2. Well, 1 is less than 2. So if I test it with 1, I should get a true statement. So 3 times 1 plus 2 should be less than 8. 3 times 1 is 3, plus 2 is going to be 5. 5 is less than 8, so that is true. So that kind of confirms that our inequality is correct. So any number less than 2 would satisfy this inequality statement. So continuing on, solving inequality is very similar, like I said, solving an equation, but there is also one big difference. The one big difference between solving an equation and solving an inequality is that when you multiply or divide both sides by a negative number, the inequality symbol must be reversed. So that's one little stipulation. So let's look at this example here and solve this inequality for n. So again, the first thing, remember, we don't like subtraction, so I'm going to rewrite this then as negative 2n, and we could change subtraction to addition as long as I make the number after it its opposite, and the opposite of a 5 is a -5. So I can rewrite that in that format. So remember, we have terms. Negative 10, negative 2n is a term, and the negative 5 is the second term. So I like to see it as terms. So again, to get the n by itself, we always go after the 0 pair first. So we will make that negative 5 turn into a 0. So the opposite of a negative 5 is a positive 5. So I need to add a 5 to the left side as long as I add a 5 to the right-hand side of the inequality. So again, the negative 5 and the positive 5 will zero out, so we can just mark those out. And that leaves me a negative 2n is greater than or equal to, and 3 plus 5 would be 8. Notice how to solve for n, I got to make the coefficient turn into a 1, which means I have to divide by a negative 2. And if I divide that by negative 2, then I must divide the negative 2, the negative 8, the 8 by negative 2. In doing so, when I work this out, the negative 2's will divide out to give me my coefficient of 1. So n, but since I divided both sides by negative to keep the truth, the inequality symbol has to reverse, so it has to change directions. So it changes from a greater than or equal to symbol into a less than or equal to symbol. And then 8 divided by negative 2 would be then a negative 4. So any number less than or equal to a negative 4 should work. So if I wanted to confirm this, what I can do is pick a number less than or equal to a negative 4. So I could try like a negative 5 if I wanted to. So negative 2, if I substitute negative 5 in for n, when I work this math out, I should get a true statement. So negative 2 times negative 5 is going to be a positive 10. 10 minus 5 is going to be 5. And 5 is indeed greater than or equal to 3, so that does check out. So any number less than or equal to negative 4 should make this inequality statement a true statement. And we kind of proved it there by using a negative 5, and it made it a true statement. As I said earlier, another thing with inequalities is a lot of times you'll see a solution represented on a number line. So if I look at these solutions, x is less than 2, what you may have to do is recognize what that would look like on a number line. So less than means I'd only include 2. So what they do on a number line is they will use an open circle, which will mean do not include 2. And then to be less than 2 means you have to be less than 2. So you have to be to the left. So what you end up doing is shading all of the numbers left of 2. Even the little arrow gets shaded in. So the solution would look something like that. All the shading goes to the left. So notice how the inequality symbol actually turns into like an arrow. It tells you which way to actually shade. It kind of says shade to the left. So here I have x is greater than or equal to a negative 3. So when it says greater than or equal to, what I have to do is include the negative 3 in the solution. So what I do is I make a solid dot where the negative 3 is located at. And then to be greater than negative 3 means to be to the right of. So I end up shading all the numbers to the right of negative 3 as well. And that's what the solution would look like if I was graphing it on a number line. So greater than or equal to solid dot. Notice how again it's like an arrow pointing to the right to shade. That kind of helps out. If I look at x is less than or equal to 1, again, equal to 1 means I have to include 1. So 1 would be located here. Make a solid dot at that spot. And then less than 1 means you have to be to the left. So you have to be shading in this direction. So that's what the solution would look like if I graphed it. It would be everything to the left of 1 as well. So it would be something like that. If we look at this last one, x is greater than negative 2. So again, greater than means you don't include the negative 2. So I use an open circle at negative 2. But greater than means I have to be to the right of it. So I don't include the negative 2, so I use an open circle. But everything to the right of negative 2 is going to be part of my solution. So we shade everything to the right, including the arrow. So it looks something like that. So that's what the solutions look like if you graph them on a number line. So another thing we may have is what's called a compound inequality, which basically what it does is it combines two inequalities together. So notice how we have solve 3x plus 4 is less than 5x, and then 5x has to also be less than 16 plus x. So that kind of gives us these two inequalities. If I want to solve it, what I can do is break it apart as two different inequalities. So I can kind of see as 3x plus 4 has to be less than 5x. That's one of them. And then we have the second one is going to be the 5x has to be less than 16 plus x. So we have that going on. So again, to solve problems like this, remember we solve them just like equations. So notice how the left-hand side is simplified, the right-hand side is simplified. But now we have to get the variable on the same side. So what we do is we pick out what's called the little guy. So the 3x is smaller than the 5x, so we zero it out. So what I do is I add a negative 3x over here, but also got to add a negative 3x on this other side as well. So the 3x and the negative 3x will zero out, which gives me then my 4 is less than or equal, or just less than, then 5x plus negative 3x. Remember, we just add the coefficients, and that just gives me 2x. And then to make the coefficient turn into 1, you have to divide by a 2, and you have to divide by a 2. So we end up with then 2 is less than x. It's best to keep the inequality where the variable is on the left side. So I'm going to rewrite that then. X is greater than 2 as well. So we have that kind of going on, one or the other. So these are both correct. If I solve this one for x, again, I got to pick on the little guy. So remember, this is a coefficient of 1. So I need to add a negative 1x over here. But I have to add a negative 1x over here. So that's going to give me then this 4x is going to be less than, and then the 1x and the negative 1x will zero out, and that gives me then this 16. And then again, to make the coefficient turn into 1, I have to divide by 4 as long as I divide this by 4. So the 4's divide out, and we have x is less than, and 16 divided by 4 would be 4. So what I pick up on is x has got to be greater than 2, but it's got to be less than 4. So if I want to go back to this notation up here where the variable is kind of, if we want it back in the middle, I can write it as a compound inequality. So x is actually greater than 2, and it has to be less than 4. So I could put this back together where it looks like this, where, again, notice how it's eating the x and it's eating the 4. Just as long as you keep those inequalities eating the right things, it should work out just fine. And typically, as a compound inequality, they like to keep the variable in the middle. So that would be an example of that. And a lot of times they will graph this as well. What the graph will look like if I kind of sketch that out. So I'll have a 0 out here. We'll put 0 over here a little bit since everything's more positive. So I have a 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Keep the graph from being too crowded. Don't write every number down. I have a negative 2 over there. So notice how we have greater than 2, so we don't include the 2, so we use an open circle there. And we have to be less than 4, so we have to have an open circle there at 4. And notice that x has got to be between those values, so it's got to be greater than 2, but it has to be less than 4, so we have to stay in between those two numbers. So that's what the graph would look like if I was graphing the inequality there. So sometimes you may have to graph and solve a compound inequality, and that's what that would kind of look like.